This video is a basic overview of a project I created combining solar heating with anaerobic digestion using food waste. It's literally a backyard project at my home in Berlin, Maryland. In the perfect world, it envisions a symbiotic energy chain where the greenhouse grows food, the food waste makes methane, the methane heats the greenhouse, and the greenhouse makes food. But it's not a perfect world. There is a law of conservation of energy, the diminished efficiency of parasitic load, and the unpredictability of nature itself. My primary goal was to sustain the production of methane gas through the winter, using transparent enclosures to contain and transfer heat to insulated environments. This current system uses Bluetooth temperature monitors and probes, on and off and duration timers for pumps and fans, and more. But it's still a labor-intensive system. I use the insulated covers to conserve heat in the cold season and to keep the tanks from overheating in the hot season. You can also see a small gas collection bag that I can monitor immediate gas production with, and the larger black main gas collection bag in the background. So gauging the weather, monitoring gas production, taking pH readings are all done by a person. Our Stage 3 version looks to utilize more instrumentation, controls, and automation. This project falls somewhere between a laboratory scale experiment and a production system, observing how materials perform and evaluating logical organization of plumbing and other design features is provided in this larger than laboratory system. And the mistakes also make themselves known on a larger magnitude than in a laboratory system. At the same time, a less than production scale prototype can absorb the cost of retroengineering and even outright failure. Looking at the components, we have the digester tank, digestate storage, solar water heating collector, the greenhouse, greenhouse solar water collector, greenhouse forced air collector, and the gas storage. The digester itself is constructed with two 50-gallon drums, with a loading port for feedstock and an outlet for digestate. It also has a recirculation system that draws slurry from high at the outlet end and introduces it deeper at the loading end. There are flow baffle plates in the bottom of the tank and a small pre-storage gas collector to observe short-term gas generation. The digestate from the outflow goes to a collection tank and is periodically pumped and injected into a compost pile of straw and what's left over from feedlot beef manure that has been strained through a filter to make the manure tea for the digester. The digestate is also diluted and spread directly on garden crops. And here's the anaerobic digester portion of the project. The tank and all its components, the digestate removal system, and the gas collection bladders. What's not shown are the monitors, probes, gas pumps, gas moisture traps, and valve controls. The solar water heating system has a collector in front of the digester tank and another collector in the roof peak of the greenhouse. The hot water passes through a copper pipe network under the digester tank. Depending on the weather, a special timer controls how often the water circulates and for what length of time and duration. Here is where there is an opportunity to gain performance by upgrading materials and increasing insulation. The forced air system, from the very hot temperatures in the peak of the greenhouse, uses an 8-inch insulated tube with a DC fan at the top and the same at the bottom, where it connects to the digester's cabinet. Here too there are timers so that the very hot air that remains in the greenhouse heats the digestate into the night. Now, the environmental issues concerning disposal of food waste and the potential energy provided by methane for heat and electrical generation is an entire topic of its own. And my own amateur exploration into this would not have been possible without the more than generous and charitable willingness of the University of Maryland's Environmental Science Department to guide my learning, take serious a look at my crazy ideas, and help me just barely touch the surface of the science of anaerobic digestion. Just in this one little project is the opportunity for others to get involved, creating what I like to call an open source forum. amateur scientists, inventors, microcircuit control buffs, photovoltaic engineers, thermodynamists, microbiologists, even creative plumbers. I'd like to hear from anybody that would like to contribute and ask questions and contribute ideas. Thanks so much for taking the time to watch this video, and I look forward to hearing from anyone interested in participating.